Start streaming. Okay. Let's wait for the picture to come through on the dashboard. Hello and welcome back again. Hello and welcome back to episode 5 of a series where we are writing a little interpreter in C++. The interpreter is going to be called NHB, which I'll explain the meaning of that at some point. It's, what time is it? 22 minutes past 9 in the UK, so I'll probably stream for about an hour or so, maybe slightly less. I've been out training at Taekwondo tonight, so possibly my brain will shut down in the next 30 minutes, but we'll see. That's also why I look quite knackered. Where did we leave off? So we're still in the process of writing the parser. It's going fairly well. We've got, just scrolling through and see quite a lot of code that looks fairly duplicated. Certainly these two is possible, and that no. I always say to myself I'll clean it up, but maybe I won't. Or I forget. Right. Where were we? We were just talking about types, weren't we? Last episode we were just starting to do something along the lines of let x equal 10, or let y equals 100. That's going to be our declaration, a bit like auto in C++, not at all like auto, because you have to declare the type. So we're looking at a full-on declare everything for the language. Doing it because it's the easiest thing to do. Post Taekwondo is some protein shake that, if you watched last week, I did not enjoy. Never traditionally drunk protein shakes. It's still affecting my throat. I've still got a cold, so I still found a bit hoarse, and I'm going to be coughing still. I might remember to mute it this time. Actually, let's try mute it. And we're back. Right. I'll try and remember to do that, save blowing up people's ears if they're on headphones. Where were we? I was talking about the double tapping the shift to jump around, which I'm clearly not doing at the moment. This ain't a very good stream. And the other thing we have to check is whether your ball is constant. Now false. Probably won't use that, but we're not going to use Struer either to start off with, but we're just putting some things in the type so we know what should go there. We'd set that when a variable is declared let, and when it's a var we would set it to not do that. Yeah. Turn that light on. That's a bit better. Then, so we've got a type struct, we've got a type kind, and I wonder if I, down here somewhere, stkind, probably, well, a quick function that convert the type kind to a const string. String. Go here. Then we will, what should we do? Switch on the kind, and we're back to this classic thing. If you watched my first streams, which please don't, because they're worse than you think I'm mad now. Hopefully I think I'm improving a little bit. But I did start this in Rust. And there are some really nice features of Rust. One of them being that you can just type derive debug and it gives you debug printing for things, which is exactly what we're doing by hand here. And it is a huge time saver. Defined to do. In fact, let's not do it to do. We would know to improve that. Technically, it doesn't need it. Clang is usually okay with it. Visual Studio. There's one compiler that likes it, and one compiler, when your warnings turned up, complains about not having a return here, and says, "Hey, your last expression doesn't return anything," even though in theory it can't go here because the switch is complete on all types, and we deliberately don't put a default in. So if you turn up the compiler warnings on the Clang compiler, it will tell you you've got if you add a new type in here, it will tell you you've got a missing element in your switch statement. But for one moment. Doesn't matter at the moment because our code base is very small, but when you've got a larger code base, just having the compiler find the errors, find the missing switch statements for you is a great aid. I use it at work a lot. It puts switches back on. When you're using virtual functions, then you create a new type, abstract virtual functions, and then the compiler tells you when you haven't implemented them. Same sort of thing. The compiler will now tell you when you've got a missing case in your switch statement. So the compiler directs you to find compiler directed programming, which often means turn your brain off for 10 minutes and just type. And that is the kind of programming which is great because it's not error prone. We don't want you to be static because we're probably going to move you into your own header file soon. Type, if we did a toStr on, we could do it now, maybe, but realistically it's going to involve generating a dynamic string to say whether it's constant, to give the user defined type and all this sort of thing, so we're not going to worry about that for now. And now let's go into print. Did it do that? Whoa, no it didn't do that. Here we go, Control plus. Varlet, isn't it? Vardef. Node kind. Mute that for a minute. So we're mostly there. Now we need to go back into our... Did that do anything? We want statement. Go back into here, we need to generate a type. So, expect colon. Expect moves past that. We get the current thing out, then we do an expect on it. But we can't. We've got a selection. Now, okay, this is going to be a boring 10 minutes, I'm afraid, more so than all the others. Just going to write some conversion routines. I64. What I'm doing is wanting to that was all of them, wasn't it? Convert from one to the other, yeah. Should learn bookmarks. I'd know it in Vim. Default. Cool. We do need one more actually. The unknown. This should never be printed. So, type unknown. So for now, it's going to be not initialized properly. Later on, what's for unknown or? Later on it will be, if we do some typing first, which we're not going to on our first cut. Tune in while I drink whole protein shakes. I'm sure some people like them, I'm sure. Maybe I just got the wrong brand. They were cheap, so on sale, maybe that's why. Where were we? Focus, block statement. Ooh, he's not a happy switch. That's because I'm not switching on anything. Kind. Here we go. void will be more useful for functions, at which point we shall refactor this out, converting types. Awesome completion. Fuzzy completion is the best. But we can do that there, do we? So, I've got a collection of drinks to try and keep my voice from going too croaky. Got some water, I've got the protein shake, and I've got some, well, I call it red bush tea, rooey bush tea, as others call it, which I've got a teapot of. Here it is, which I shall endeavour to try and drink most of. Yeah. So, where are we? We need to default the... Okay, this is getting to the point where I am actually going to have to start breaking some of this up. Default the kind to type. Yep, so it defaults to that, so it was all initialized. IST nodes are becoming gradually more and more weighty. But we can cope with that. Right, where were we? We've got this going, we advance past it, we've now got define, we do the logical thing, put that in the first child, we start the type, see if it works. Expected kind was not found. Makes me sad. Expected kind was not found. Statement. Debug. Something about me forgetting breaks. A while back, I got, this is pretty geeky, I got interested in what coding mistakes I make, just little ones, you know, like forgetting that break there, or you know when it doesn't build or something like that, run at least. You know, not necessarily big logic mistakes, although I did track them, and I tracked them for about a week, and it was fascinating. First of all, the very fact I started to write things down meant that the error rate greatly reduced. I found myself checking the code much better before I even bothered to compile. And one of the things I noticed was the use of const did not help. Locally use of const, so making that const. At no point did I ever have I found a bug. I've become sensitized to it at that point. No point did I find a bug where having a const there would have helped me out. There were some other results. I did write them down somewhere, but I'd have to dig them out. But that was the one that stuck me, and I just kept watching. I'm still waiting for a const local variable to help me out. I've actually stopped writing const half the time. I used to be a huge fan, less and less so, become less so when Moose Semantics appeared and const was stopping that. And it wasn't warned up or errored on the compilers. I don't know if the Clang checking tools does that now. I'd have to check. sure it does. Yeah, a little bit of a detour into the weird world of me. What are we doing? We're going to figure out why that wasn't printing. You see, my brain is not there. So, is this where we're meant to be? Yes, we're in print. Because you have nothing here. What did I do a minute ago? Variable def. No, that's right. That's a function def. Okay. Brain is definitely not working very well. And I keep forgetting to do that. Well, that was useful. We're not adding it. Which is logical, because that's probably the only thing that could be going on with it. So, F8 all these. First child is null. Right, so we want to step out of this function. Go on, Shift F8. And we want to step in. Ooh. What are we doing? Statement. Ooh, look at you. Little insidious auto there. I should turn my warnings up. But no, I'm not going to do it on stream because that'll just be so dull. Fiddling with compiler warnings. I'm pretty sure that I just used the default CMake file generated by C-Line. We kicked this little project off. And it's fair to say I probably need to turn the warnings up. I usually run at least warning level 3. I often put in as errors. Maybe when I'm deving tappy Franklin code in, we maybe when we Franklin code in, I don't worry about warnings, but I do clean them up quite rapidly. They bug me. Right. Let's see whether that did something. Variable def x. And why am I not seeing what I want to be seeing? Why am I not seeing that? Because I did not put. Excuse me. It's a bit crude to do streaming, sorry. It's I32. Awesome. Let's see if we create a ball and assign the wrong thing because, you know. Should we create a void? The void is true. Ooh, interesting. juice. Have we done true and false yet? Apparently so. That's weird. Normally you get 2 right. Third one works. I'm not imagining how I did. Semicolon expected. The moment that annoys me enough, I'm going to start improving the error messages. Awesome. Now let's do what we was doing. Hey, why not? I mean, why don't I check? But what are we not displaying? The initialization expression. Print. Here we go. I assume that's coming through. As you can see, yeah, little pretty printer for the ST is. Streaming's okay. The pretty printer is showing exactly what we're typing, as you'd expect. Okay. Right. We've got code blocks. We have done var-defs. Let's take you off Alice. Have we done an if-net? No, that's an expression. While. Is it a while statement or while expression? Do we want to return a result? So do we want to be able to write something like net x int equals wow y equals 50. Okay, 3. Assuming that's an expression that returns a new y result. If not, do something like that. We're not going to have braces around here. Probably would do something like that. Which should be very minimal, wouldn't it? But for now we're going to have loads of braces and we'll chop them out as we go. So that's going to give us a 30 assignment. No, let's not do that. While is going to be a statement, so you won't be able to assign to it. So you can still do while x greater than 100. Do stuff. Have it like that, I reckon. Excuse me. Right, so statement. So we need to go to. We need to write our little syntax tree. Wow. done equality assignment. We haven't done assignment. Got these statements in there, and for now, to be super regular, you're going to have a return there. Not a return, a semicolon there. Right, are we clear what we're doing? No. We want that. What we want to do is in here. If we write this, we're very clear on what we're doing. Print. We end up doing this on every single one, we can shove it up. The condition. And that code block. And that will be our while statement. Now, we're not there yet. God, why don't you just press return? You've got let, which is massive, so let's keep you at the bottom there. Case. I think it's STM, no auto, new node, while statement, stop, and technically that is not right, so we that was a Visual Studio keyboard shortcut. Same with you. Get the line number right. You get the line number right. Sure, I remember. No, I'll leave it there for now. Advance. Now stm slash first child equals log comparison. You see, now we don't have a pointer problem. Oh, we've got to build a pattern for this. No, I definitely want to do some sort of local comparison. Followed by code block. Sure, it's going to be interesting adding some messages for this. Which we'll come back and do another time. Guessing that's going to work? No. Checkout break statement. Come in, we've got a while statement. Create it, create the new node. Advanced past the while statement, so on to the next one. Create a builder. Pass the logical expression. Pass a code block. What more can go wrong? Something. That was not expected. What are we saying here? Put that there, that's not going to fix it, but oh, it might do. Yeah. I just love it when you go wrong. Slightly confused by that. Should get this breakpoint before we get the next one. Yes, 7. Got you. Why are we going back into a statement again? I've got an L code, I know. I've got identifier. I don't think so. I apologise. Right, let's check the tokens that are coming out. Code block, yep. Wow, yep. Identifier, yep. Greater than, yep. Some number, yep. Curly. Where are we at now? Identifier. Multiply. Identifier. Semicolon. Curly. And another semicolon. And that should be end of file. Yep. Good to go. Over here. We just see what Lex is at. Is that the while keyword? Yep. So we advance past that. Go to identifier. Put an L curly. passing a code block. So we come back in again. How's that got to the identify? I keep reading the begin. I might get rid of that begin because we don't actually need it. Semicolon, arc early. Get the semicolon. Now trying to do a end of file. Why did it skip the semicolon? Nested curly braces. Oh, I'm glad that's gone. More tea. Way too much. Well, let's find out what's going on. Scroll down, let's look at the code again. See, an error in my code. Perfect. That would teach me one thing very obvious, that I need better messaging in the parser because I'm making mistakes as I'm writing. So let's check that out. We've got a while. I'm going to go for an indent of 1 actually. That didn't look very nice in the end. I thought maybe it would. Maybe it would look better. We've got a module that consists of a code block. We may remove that code block soon. We will remove that code block. Then we've got a while, a greater than. We've got the while loop within a code block. This is our expression, so look up a variable x and compare it to if it's greater than 50. Then we've got a code block, which just basically multiplies x and y. Cool. While loop's done. Well, probably this is the next. Let's specify if statement. Consists of if logical expression code block. Then we've got an optional else. Code block. What this doesn't let me do is let me do else ifs at the moment. You know what? We want that. Okay, I'm overloading what square brackets mean, but you get the idea. That is all we are doing. Make it clear by going up and doing our in here. interpret it is a different manner in the end of the day. What's going to do is, if you do an L-thief tree, it's actually going to be a ladder of lots of indenting. I'm just trying to think whether that really matters. Other than the pretty printing, I don't think so. If some expressions say they can return a value, they will return the last thing evaluated. It's not going to have a missing semicolon or anything like that to return a value. It's just going to be whatever the last thing is, gets returned out. Types have to be the same, with the exception that if they're not being assigned to, as in they're being used as a statement, the return type's void, and we're just absorb all things into the void. Into Atom, what time is it? You know what, I think I'm going to call that a day tonight, and it's done for streaming. I may carry on an active statement. It's not that exciting. Off stream, what else have we got left after this statement? Much we've got assignments and function definitions. Which won't take so much longer to get through. Once we're there, we can then do the next stage, which is got the syntax check. Well, we've got to improve the errors. After we finish getting the path tree, we have a few things we have to do. Prove the errors. Error maybe error recovery. Allowing multiple errors. Type check. And creation of symbol tables. That will be two passes. We shall walk the AST, creating symbol tables for every new scope, which is a code block or function call, because we have to put the function parameters in the code and make them const. Whatever. From there, we've got the symbol tables and we've populated them. We then start the process of making sure all our types are the same when we use them. We're going to explicitly not allow conversion of int to int64s, and vice versa. Initially, anyway, to just to stress test our type checker. Balls are not going to implicitly convert, and nothing's going to implicitly convert to a ball. So you're not going to be able to do while x plus plus or something like that to try and get it to 0, which would be off doing x equals 0. But we're going to take a leaf out of C# book and say, nope, where we expect a Boolean expression, we want a Boolean expression. We're not going to, when we have pointers, I don't think we're going to do while x or for, that sort of thing. We have to do explicit checks against null. If we allow pointer walking. Sure we will. Right, that is it. Hopefully I'm starting to improve in the streaming. We're making good progress either way. Hopefully my coughing's starting to reduce, and I'm getting pretty tired. We shall resume maybe tomorrow. What day's tomorrow? If not tomorrow, then got a busy weekend, so it will probably be Monday or Tuesday. Okay, thanks a lot, and see you. Bye.